Yeah, from the bottom it goes to the O2 sensor. From O2 sensor,
Which one is O2 sensor?
this is O2 sensor.
This is O2.
Yeah,
this
is O2.
body, full body is
Full
O2.
body is a O2 sensor.
CO?
Hmm?
CO? CO?
CO is this one.
CO is this. This
This
full
is the
pot.
detector. Yeah, this is the detector for CO. This is the filter for CO.
Okay.
This is the chopper motor. You can see the motor is running.
Mm-hmm.
So you can see from here whether the chopper motor is running or not.
Okay. That is running. Now
Yeah,
also running.
Now it is moving. That means the chopper motor is running.
Okay.
This is your IR source.
Okay.
This IR source is connected to the motherboard here.
Mm-hmm.
This one.
Okay.
So how to check the IR source is working or not? Switch off the analyzer.
Okay.
Remove this one and measure the resistance. It should be close to 7 ohms.
7 ohms.
Yeah, close to 7 ohms.
We can check now also?
Now it is on. No?
No, it is on. No, okay, we cannot check. Okay. 7 ohms only.
It should be close to 7.
7 ohms. Chopper. For chopper checking.
For
Okay.
chopper. And then this is for this to make sure this is working or not. There are some parameters.
Okay.
With that parameter, you can verify that
Okay.
whether the detector is working or not.
Working.
I will give that parameter.
Okay, okay.
This is the cable for the chopper motor.
Mm-hmm.
It is powered by motherboard. It is coming directly to the chopper motor. Individual chopper motor you can replace.
Mm-hmm.
Your IR source you can replace. We have 2 screws. You remove this and you can replace the
IR source. Okay.
Similarly for CO, you can remove these 2 screws.
Yes.
And you can pull this
Backside.
detector.
Pull back. Okay.
Whenever you are replacing the detector, you have to first remove all this tube 1, 2.
Okay.
Remove IR source, chopper motor, detector.
Okay.
This is your detector cable.
Okay.
And then there are 3 screws here behind.
Okay.
It is holding this whole panel.
Yes.
So 1, 2, 3. Those 3 screws, if you remove, this whole body will come out.
Will come out. Okay. Only for CO. Only
Only
for
for
CO.
CO. Yeah.
Okay.
And then you can replace the detector or your IR source.
Okay.
Anyone.
Okay.
Don't try to replace the IR source and detector fix inside.
Inside. Okay.
You remove this whole assembly outside and then you replace because you don't have space.
Yes. Yes.
You know, and you will try to do this and you will damage some other things.
Mm-hmm. So when we remove these three screws, this body will come outside.
The whole body will come out. But
so after we remove this hose pipes.
No. First you have to remove
hose
1, 2,
pipes.
3,
Okay. 4 hose pipes.
Yeah.
4 hose. Okay.
Yeah. So 2 sample in and
2
out.
sampling out.
One detector signal, chopper motor signal, IR source signal.
Okay.
Okay, 3 electrical, 2 pneumatic sample.
Sample. Yes. Okay.
Once you do this, then only go for removing the
remove
screw.
this. Okay.
Then take the whole body out.
Okay.
Okay.
Then we can remove this one and this one, etc.
Yeah. So this
chopper.
2 screw you can remove this detector out.
Okay. Chopper motor, how much voltage will go?
Chopper motor is a 5 volt DC.
5 volt DC.
So
Okay.
yeah, we cannot measure that voltage as such in this cable.
Uh-huh.
But if it is working, it's working, or else we have to just replace it.
Okay.
Most of the time it will get stuck if there is a lot of dust.
Uh-huh.
It will get stuck. You just have to put some WD-40
Okay.
on this and it will start running.
Okay.
It is very seldom that chopper motor will fail for Ultramat 23,
Mm-hmm.
unlike Ultramat 6.
Only required WD-40 only, not
Like
contact
this
cleaner.
is what my practical experience.
Acha. Okay.
Nothing written in the
There is
manual.
any sampling cell is there for CO? No.
Yeah,
Yes,
this is a
this
cell.
Sampling cell.
This is a cell. In
This-
and out.
So
This
just
is the
we
cell
need
and
to
this is
keep it as
detector.
spare. Just we need to keep it as spare.
Okay.
So most of the time the sampling cell is a issue.
Okay, sir.
And what about the O2 area?
So the O2 is this is a paramagnetic type O2. Yeah.
It seems very small compared to the another
Previous
one.
one, yes.
Previous one.
Yes. It is very small.
I thought maybe it's a normal one or
No. It is a paramagnetic one.
okay.
But it's like a dumbbell type one. So it has a magnet which is keep moving. Now in this, what happens is that you cannot replace any individual spare. If you see the spare list also, no, you will get a whole body. You just have to remove 1, 2, 3, and you have to replace the whole body.
In the last one we had a measuring head. In this one measuring head is not there.
No. There is nothing like in the oximet. What they
Yes.
do is they run nitrogen and instrument air.
Yes. Yeah.
Sample air.
Correct.
So they need a cell
Okay.
where both the sample will come, flow, and across the magnet. Here it is not like that.
Okay.
Here what is happening is it's a dumbbell type. So whatever oxygen will come, it will see the vibration based on the amount of oxygen,
Okay.
and it is only calculating that vibration. There we have a flow cell which will compare between nitrogen and
Yes,
so
yes.
you need the whole sample cell.
Okay.
If this is the measuring cell, no? If this one inside maybe salt or something going, how to clean this one?
So you have to remove this.
Okay,
cell.
that understood. But for this one screw from this side.
No, this is the screws. these two.
Okay.
These two, when we want to clean this part, then you need to remove
Okay,
all
that
parts and
understood.
then need to remove this one, and then we need to remove this one. After that we can clean like this only.
And
Before we removing this glass, no,
yes,
old
yes,
one.
but he is telling first remove the complete unit
Complete-
outside,
complete hose
then
pipes.
one by one
Then
DSM1. But I think glass is not there in this.
That
Glass is there in this?
Yeah, yeah. This
Is
is
there?
sample cell.
Okay. Maybe it is there when you open your Okay, in the last one, oximet,
Yeah.
we had a sampling chamber was there. No? You last time you replaced that one.
Yes.
Is it available in this one? Or
No.
Nothing.
That's what I'm saying.
It is not there completely.
Because of no nitrogen, no
Yes.
reference, there is no difference happening.
Yeah.
So you don't need a sample cell as such. We don't have the sample cell here because we are not running nitrogen here
Okay.
as a reference.
So
whatever
means
the
if you want to having any problem, means you have to replace the full unit.
the full unit, yeah.
Okay.
We don't have any spare
Any
for
common
individual.
part number is there for the
Yeah,
full
yeah,
unit? Or?
yeah. It's
okay,
a,
it's
there is a
available.
part number available.
And what is that? That is the pressure switch or what?
So this
Yes.
is the pressure switch.
Yeah.
This is a switch which will tell that whether there is a sample or not during autocal. And this switch is connected across this flow meter.
Okay.
So if you have 50% of the flow here, then this switch will be close.
Will
It will
close.
be close.
And there is what is that? The yellow color one is the filter inlet side or
It's an inlet sample filter, yeah.
inlet sample.
That one we cannot clean inside individually, remove and clean. We can.
Yeah, we can. You
We
just
can
have to remove the clip
remove
from
this.
there
Okay.
and pull that everything outside
Okay.
and remove from
This
outside.
bottle will come open. We can open like threaded.
No.
Threaded
You have to replace it.
Replace only
Yeah,
directly.
It's all sealed one.
Acha.
And it
Okay.
is supplied, but they call this.
Okay. This PCB only for CO.
No.
This-
This
both.
motherboard is for both CO
For
and
both.
O2.
Okay,
Now
both.
this sensor signal is also going to motherboard.
Acha.
Okay. There are three channels. 3 IR it can take, but we are using only one for CO.
Okay. If in case this side any problem, we can change this one.
No.
also.
So every channel is defined. This channel is defined based on the jumper.
Okay.
So this is jumper means channel 1,
Channel one.
and this motherboard is configured for channel 1 as a CO.
Okay.
So you have to connect only X35 only. So you have 35, 36, 37. So you have to connect here in this location only. You cannot swap in any other location.
But now it is 38.
Hmm?
X38 it is.
Move your hand.
Mm.
So okay. X38, 39, 40. Yeah, 38 you can.
Oh.
So whichever is the first one, you have to replace that one. So
And what is this black color one in the center? It's what a regulator or
it's a condensate.
condenser?
If in your sample you are getting water condensate,
Yes.
so first thing is the sample will go through the sample flow meter and it will go through this condensate.
Okay.
Based on the gravity, the water will drop down,
So how it will come out?
and then the outlet of this is connected outside at the sample out here, the big tube.
Yes, yes.
So that we need to take it out.
Yes. So that will go out by itself. So to the maximum extent, it will avoid any water to go inside.
If we need to clean it, how will just open this top
Any
side
filter
or what?
available inside?
No. What you have to do is you just run the air, and just it will get cleaned up. Just run the air.
I don't know what inside this.
It's nothing. Sample will not flow down. Sample will only flow up. So the water will go down. Because sample is lighter,
Yes, yes.
so it will flow through the other tubes.
Last time, you were adjusting from back side for that.
In
And
this, no
one,
required.
Not
No,
required.
The reason is we don't have a reference cell in this.
Yes.
We have only measuring cell. The reference is in the PCB. The Wheatstone bridge, the bridge is sitting in the PCB. So they have set one reference. That reference we are setting it with the feedback resistor.
So what is this heat sink thing outside they have put in?
This one?
Yeah.
Because this cell will be heated at around 40 degrees C.
Okay.
So they want to retain that temperature.
Fine.
Because the IR absorbance is more dependent on the temperature of the cell. So we are heating this cell. This detector is getting heated up with the power from here. So we will heating it up until 40 degree. So whenever you see that the analyzer is warm up. After warm up now it is not going for any
Auto calibration.
Measurement,
autocal
measuring.
because you don't have flow. After that you will have C here.
CSS.
C means it is cool down mode now.
Okay.
It needs time to warm up. So that's why what we say is that whenever you power off and power
Yeah,
on,
from yesterday we were seeing CO only.
so you have to keep it on air for 1 day. Just keep it for air for 1 day. By
Okay.
that time your cell will be stable. Second day you come, you just put your sample, it will start measuring.
Okay, what again about this reference PCB?
Yeah. So in other models, we have
the references.
here
yes.
the reference resistor is already built in.
Okay. How is calculated the reference? It is always fixing here.
No, with the feedback resistor here.
Feedback from where?
Feedback resistor is soldered there in the PCB.
Fixed.
In
Okay,
fixed
it means
bridge.
it is fixed
Yeah.
stone bridge.
Yes.
Fixed one, and you take the reference from this fixing one.
There is
Yes,
no
this
nitrogen
is your
required in
reference, and you are measuring. You will keep comparing with this resistor. How much is the difference?
In this analyzer, no reference gas required.
Yeah,
What we
okay,
are
okay,
having
but-
there. NO.
But how's the accuracy of this?
Accuracy, how it is? It is
Yeah, it is accurate for all the SEMS wherever it
Because
is.
the
installed.
reference gas, I think it will be more accurate.
Nothing as such. In reference gas, you are already always dependent on that cell. How much reference gas is sitting inside? We don't know inside the cell whether reference gas is active or not.
We don't know
But
also
in
that
this-
the resistance here, it was
No,
also
that you can monitor here on the.
also the ohms you can monitor from
Yeah,
there.
the
Where?
resistance, impedance. There is an option there.
he will show you.
You can run the pump now. Well, Ultramet 6 is more of a process analyzer. This is more of a SEMS analyzer. Because this has an option to do a calibration with respect to air. Because our reporting to environment will be always with respect to air, not with nitrogen. But when it is a process plant where it's like a petrochemical or oil and gas, they always take reference as a nitrogen.
Yeah.
So you have a flow here. Now
Yes.
what it is doing is after warm up it will try to do the zero. So during this time you have to make sure that you are running with air only. So now we are sucking only air, right?
Yes.
So what value difference comes when you are doing with zero gas and air? The calibration.
No, in air you always have some amount of CO.
Yes.
CO, NO, you are
Yeah.
always having it.
Yeah.
Okay, when you are running nitrogen, what you are doing is you are taking that value, you are not considering that value in your curve. So what happens is that when you put it in the air and you don't have any CO, you will see a minus value, negative value. Because you have not considered the CO, NO of the air. Here what they are doing, whatever is there in the air, your normal air, that
Okay, tell me about this transformer. How many output going where from where? All are coming this only, here only?
yeah, first one, and then from here it will go to the main model.
Here how much voltage?
Here 12 plus 12 voltage, 3 pair.
3 pair. Okay. Here same.
Same it will go.
Okay,
Well
12, 12, 12.
distributed, yeah.
12, 12, 12. Okay.
What's this serial port or what?
Sorry.
This
Serial
one, this one,
port.
serial.
This is to connect to the software.
Software.
Yeah.
So
this
there
is
is no any other for connecting to PLC?
for PLC. If you want to connect to PLC, then you have to connect a Profibus card here.
Okay. So Profibus card where it will be?
It has to be fixed here,
Okay.
and this is the connector for the
Connector
Profibus.
for this one. Okay. So here there is any digital output available for?
Yeah, by default you will have a digital output common fault alarm from here.
How many?
You have the
common
list,
fault alarm.
Yeah, common fault alarm.
No, for starting is some solenoid or some pump and all this one.
Yes,
We
we
can
can
do
drive.
it?
We can drive it. Yeah. So you have this 7 connector.
7 relays.
So you have total 8 relays.
I can configure these relays
Yeah, accordingly, whichever you want. It's a configurable release.
from here.
Yeah.
Okay.
But analog output remains the same. Analog output, one is for channel 1 only. So that is connected to X38.
Okay. And the other?
Yeah, for second, yeah, but for your case,
Yeah,
only
but
one.
You must
only
switch on
one.
this light. Here, first button. Yes.
Okay.
No,
This
that
is the
one.
9 pin for the software. This is RS485
485 for the software.
for the software.
So
Yeah.
you supply the software with this one?
Software is free.
Free from internet and all that. And it's a cable connection?
Cable you need based on the laptop what you have. If
This
it
is normal RS485.
normal for 485, yeah. You have to connect to 3 and 8. 3 and 8. Yeah.
It is a standard one, so I can get the standard cable from the market. You have to work.
Yeah, it should work.
Okay.
It should work.
Through software, what I can do this backup parameters.
Yeah, you can take the backup of this motherboard. You can keep the backup. If in future if the motherboard fails, you're buying a new motherboard, you can upload the configuration file. Yeah.
So there is any other benefit from the software or only the backup?
Technically they use only for that because all the other function you can do from HMI itself. You don't need to depend on software.
But just now the analyzer is in factory settings, correct?
Yes. Okay, so
If in case we connect in the system, this like this HMI we cannot control from system. Means this is HMI, we can control it, we can measure and whatever parameters, etc. We can see here, we can see and calibration, etc. We can see here like HMI. This one is HMI.
Okay.
This like this HMI available in system software also. No.
no, not HMI. It's software will be like more kind of parameters.
With the software we cannot controlling anything, etc. Parameters, calibration we cannot do. Only in keypad, with keypad only we can do.
Yeah, with software purpose is not to do calibration. Software purpose is different. If you have to download the.
What is this hash mode?
I'm coming to that. So you have 4 parameters here. You have analyzer status. In the analyzer status, you have status.
Yes.
And then you have the logbooks.
Okay. Yes. The logbook false.
So flow to low during autocal.
Okay.
So when we were doing the autocal at the beginning, there was no flow.
Yes.
So because of that, this switch has given a command to the motherboard.
Okay.
Now what are the other message you have? You have only one message. Okay, that is flow too low.
Okay.
So only flow issue was there. Other than that, everything was okay. So by pressing enter, you will clear that alarm.
Yeah. Okay. If flow will be low, that
alarm will
doesn't be clear.
No, it will not clear. It will again come up.
Again come. Yes.
So when you clear again, you have to go to the fault and you have to see if the same fault is there or not.
Okay.
Yeah. So that is your regular practice. Maintenance request. Maintenance request will only come if there is a problem with your IR source or your detector. Okay. So those detail will come here. And if you are doing an calibration and it is out of the deviation, then that alarm will also come. So what deviation are we talking about? We are talking about maximum allowable 6%.
6% deviation.
Yeah. Then this is the O2 sensor status. What is the status of O2 sensor? So you are presently measuring 37.83.
Yes.
Yeah. When it reaches 30 millivolt, at that time it will give you an alarm.
Like a maintenance request.
Yeah, maintenance request.
Okay.
By 20 it will be fault. So when it reaches to 30, at that time you have to look for the replacement of the sensor. Yeah. And then between 30 to 20 you have that 10 millivolt period where you can replace the sensor. But
usually how much it will be?
37.87. Now this is very important diagnostic value, IR diagnostic value. Now when we say IR diagnostic value, we are talking about CO. So you can see in the CO, IR diagnostic value, you go inside, you have a lock-in analog to digital converter plus temperature.
Okay.
This is the place where it will tell you what is the resistance of the measurement.
Okay.
Okay, now this R is the value of the Wheatstone bridge. Now
how much it will be there?
Yeah, I'm coming to that. So you are now around 507,000. Okay. This is a digital value. It is nothing with analog ohms or mega ohms, nothing like that. It's a digital value because the analog to digital it is already converted value. So these are counts actually. So this is around 500,000.
Okay.
It should be minimum. It should be more than 250,000.
Okay.
When it comes to 300,000, 300 or 280,000, that time you should make sure you have the spare for CO detector. We cannot do anything. We cannot do any adjustment. You have to just replace it. So anyway, but you have around 250,000 of resistance. Now what is this resistance? This detector is filled with gas. So based on the absorbance, it is giving you the value. Yeah? So that gas, it will deteriorate like in 3 years or 2 to 3 years time. It will deteriorate. That deterioration you can read from here.
Okay. R means?
R means resistance.
Resistance. Okay.
So this is a very important parameter. If you keep an eye on this parameter, you are keeping an eye on the detector.
Okay. Our minimum 2,500, 2,50,000.
250,000.
250,000. Okay. Maximum?
No, there is nothing like maximum.
Maximum means
Now this is a new
50
detector,
lakhs.
so you are measuring around 500,000.
500,000. Maybe 1,00,000 it will be.
It will never go high.
Never go high.
It will drop from here now.
From here, okay.
If it comes down, replace this detector.
We need to change it detector. Okay.
Yeah? So this is one parameter which you have to focus. The other parameter you can check the manual. You will keep getting the values.
Okay.
The important things only I am sharing with you now.
Okay.
O2 diagnostic value, here you can measure, you can see the sensor signal around 1300 millivolt.
Okay.
Yeah. But here also we cannot do it, is only for observation.
Now we just saw IR only, CO only.
CO is
CO
IR.
IR. Yes, yes.
O2
O2 is
means, your,
here sensor,
O2
sensing
sensor.
millivolts. Yes, yes. Okay.
The other parameter are now this is the analog output.
Yes,
How
yes.
much analog output it is giving in the loop.
Yes.
So you can see if you want to verify the range at the DCS, you can see how much is the output. So
Okay.
it is 4 milliampere
4
and 7.35 for O2.
O2. Yes.
Okay.
Okay.
No, 7.35. Why they are giving? What is the range of O2?
We can see now.
Okay, so diagnostic value.
Diagnostic value.
Factory hardware is just to see the serial number.
Serial
There is a
number.
serial number of
Model
the
number,
device,
version
model
number, etc.
and all this. Same way for the software. What is the version of the software?
Okay.
We don't do anything in this. Before going for calibration, we'll see the parameter.
Yes.
What is the measuring
Measuring
range?
range.
Here you can see
CO.
the range. So CO is
Switching range.
switch range. It should not be automatic. You have to select any one range.
Anyone.
Better.
Okay.
So your loop current will be stable. So what is your actual range now?
Actually, 0 to present cylinder. No.
No. How much is the range in the
4,000.
DCS? CO range, how much is in the DCS?
20,000 ppm.
20%.
Yes,
Yeah.
20, not 20, it's 2%.
20,000, 2%.
Yes, 2%.
So you select only range 1.
Range. Okay.
Yeah? Range 1. So
This what is, how much the scale is this one?
no, they have set up two ranges. One is 0 to 2%, one is 0 to 10%.
Okay, 10%.
Yeah,
Maximum.
but this switch range, what will happen if it reaches around 1.8%? What it will do, it will change the loop current
Automatically 10%.
to 0 to 10%.
10% automatically.
So we don't want that to happen. If it
Yes.
goes more than 2%, show over range.
Correct. It
So
should
we
be
have
like this.
selected actual range as
is
range 1.
Range
Yes.
1. Okay.
Okay. Whenever you do any changes, you have to press measure
Measure. Okay.
and accept the changes. Yes, go
Yes.
here.
Go to the measurement. Okay.
Okay. So we came here now. Okay. Now let us go again to parameter. So now we know what is the range of a CO. CO should be range 1, 0 to 2. So whatever you are selecting, your 4 to 20 milliampere will be configured to that range.
Only 4 to 20. 0 to 20 is not there. Only 4 to 20.
Only 4 to 20. That also we can see. We can
change also.
We can select here.
Acha. Okay.
Okay, measuring range. Now we did for CO. Now let's check for O2. O2 we have switch range. So first range is 0 to 2%, second range is 0 to 100%. How much is the range in for O2 there in DCS?
Actually, we have
0
to
to
do
10. 10. 0 to 10 only.
So you can change here.
Here we can put one only. One. Then
I
we can.
will
This
change-
one also we can edit.
We can change.
Acha.
So now we are in switch range.
Switch range.
Yeah, I will
Then
go
we
to change,
range. Okay.
and I will change it to 10 range.
0 to 10 is. Okay.
Enter.
What is the meaning of 0 to 100%? Already O2 is only 21%.
No, in some cases they are using this for oxygen plant also.
No, but the scale in this one will be 21%. Or it can go.
It can measure until
It can
100%.
measure.
Yeah. It is written there.
It can measure. It's okay.
Yeah. It can measure 100%. It is nothing. They are just plotting the curve.
Fine.
That curve should be there in the motherboard. That is all. Okay, now it is doing autocal. Now what has happened? The first autocal we did. After that, it waited for the temperature to rise.
Okay.
The temperature has came to the set point.
Okay.
After that, again automatically it will do autocal. Now we will try to remove the autocal after warm up. We'll see because I have never done it. We will try. Because autocal after warm up is kind of a mandatory from factory.
Factory. Acha.
They always say after warm up you should do auto zero.
Yeah, it is okay, but sometimes just a reset is required or something that we are making, then it will go. And by mistake, our people didn't remove the measuring, then it will.
Yes,
In
it will be wrong.
in autocal
Disturb the
position
conveyor.
should be pump should be open condition.
Yes.
Sample gas will
Yes.
be open condition.
That you have to mention it here.
Okay.
Keep it here.
Okay.
This is it. If you make mistake, means full calibration is disturbed. And now for you are keeping it topside, means no zero gas required topside,
Yes.
only CO.
CO only.
And
Okay.
O2 for cross checking. Because O2 also you will calibrate with the atmosphere.
What is these two connections? One and this one, and this one and this
Here,
one.
there is a power there. Which connection?
This one and this one. One is
This is your see. This is the big tube is where your liquid get drained. This is your vapor will go out.
means these two are exit only.
Exit only.
Exit only.
Exhaust.
These two and plus this one also, 3 also.
Which three?
This one also
This
went
is in-
only. Gas outlet. This
Yeah,
one.
only two, no? The liquid drain line, another is a sample out.
Sample out. Okay.
This is filter, no, right?
Yeah. Now see, you have CC, yeah. Now how to know that the cell is already heated up? You press 2 times measure.
Okay.
There should not be any C here. Okay. If it is not heated up, then it will show C.
See again. See means
Yeah.
cool.
It is in cool mode.
Cool
So
mode.
if it is C, then keep the sample out.
Out.
Remove the sample, let it run with air.
Okay.
Okay, how much temperature it should reach to,
Actually, it
and
should
where
go,
we can check?
Yeah, we can see it here. Diagnostic IR. See, this is your temperature, 32.9. It should go at least. It has a two thing. One is a timer. There is a timer inside inbuilt. What it will do? It says that it will reach until 32 or 33 by another 5 minutes or 7 minutes.
Within time it will reach. It will not show.
Yeah, it will detect that okay, we have reached to this optimum. But 33 also not good. When you will install it and you after 1 day, if you see, no, this will reach until 39.
Achha.
Yeah,
Means
it is,
30.
because there is no controlling as such. It's a small circuit where it is keep heating up.
No, because this will be in the AC room, so
Nothing will happen.
Nothing.
Nothing will happen.
How much is required stable continuously?
Minimum more than 30.
More than 30.
Minimum more than 30. And anything more than that is based on the sensitivity of this gas.
Gas.
You know the gas when you heat up, when you're giving heating up, it can heat up until 39, it depends on the type of gas you're using. Yeah, so we have seen the measuring ranges.
Yes.
Yeah.
And changes, measuring changes also.
And the rest
Limiter.
all, now you don't have any external pump here, okay?
Yes.
So if you press this one, no? If you press this one, nothing will happen.
P1,
It
P
will
means
come
pump
P,
on off.
It
On
will
off.
come P, you have a digital output, you can use that digital output to run the pump.
Uh-huh.
You can give that
Okay,
input
okay,
to the
okay,
pump,
okay,
to a PLC
okay,
or to a relay,
okay.
and you can run the
Then
pump.
then the pump directly.
Then the pump will run.
Means inbuilt pump is not there.
Until there is no pump.
Okay, right.
Now let's see the analog output, then we go for calibration.
Okay, that one is 24 volts only, or it will generate 230 also. Whatever we are giving, that
No,
one
this
will
is
generate DO only. Only
It's a DO to the relay.
Relay only. No, for DO also control voltage is required, no? Not required.
It's a dry contact.
Dry
No
control.
voltage.
No. Okay.
Okay, so we are at configuration, input output pump, yeah, analog output.
Analog output. Analog output
Okay,
ranges.
here, how should the analog output should react when it is in fault condition, when it is in hold condition, when it is in auto zero condition,
zero, okay.
because you should not report any wrong value to the DCS. So here you can select that one. So first of all, measuring value, do you want to measure negative value or not? If the value goes negative, the loop current should not go less than 4.
Yes.
It should stay at least minimum 4. So what you do, it is in on condition, measure value negative, you switch it off.
Off. Okay.
Okay. Now range 4 to 20 milliampere. Now if you want to change Namur 0, 2, whichever you can select from here.
Okay.
And then now I have changed it to off, so I will save it.
Save. Okay.
Okay. Now let
Save means measure button.
measure and enter.
Enter. Yes.
Similarly for configuration we will go assign relays. Okay. So
Relays
if
for
you
relays.
want to actuate any wall, so you go to wall and then select the relay. For zero gas, you can select one relay. For span gas, you can select. But that cable from the back side, you have to take that cable and you have to connect it also.
Connected, yes.
If it is not connected, it will give command,
only.
but it will not have any actuation.
Yeah.
But if you are doing manually, then no need of all this. Yeah. Similarly, for status, if you have a common fault, you can configure the relay. Which relay should give common fault? So if it is relay 1, you can connect that cable which goes to the DCS as a common fault. Maintenance request and whether the system is in calibration mode or in measure mode, that also or function control. If someone has came and he has went inside the function, and if you want to see that has to be reported in the DCS, that also you can select it.
Which time something what happened we can
Yeah.
see also. Okay.
Okay, so these two things are very important, analog output and this. One more thing. One is the loop, how to do the loop loop testing. No. Analog output. So output during function control. Function control means if you have given the passcode, then it will go into function control mode. So at that time,
yes,
what should be the output? Whether it should be the actual value what you are measuring, it should be 21 milliampere 0 or hold. Hold means the last value will
Last
hold.
one will do. Yes.
It will hold. So you have to decide on this one. Yeah? Similarly, during fault, what should be the value? So if you want to put it on hold, it will remain on a hold, last value. Okay. So this you have to decide. During the fault condition, what should be the loop current? You can decide from here. If it should be the last value which should hold, you have to select hold here. Presently, it is in actual. So if you want to put on hold,
No, actually. Only you should not show the negative part.
yeah. So then you have the loop testing. You can check the loop input output. So we used to do the loop checking for the analog output. Now analog output 1 is very specific for X38. That is for CO.
X38.
Yeah, in your analyzer. Analog output 4 is for O2.
Okay.
Okay, so once you connected this cable to the DCS, from here you can simulate the current and the same loop you should get it at the DCS.
Like a source
connect
meter.
a Profibus card, then what will be the
Profibus means
do
you
I have to make this a digital input output?
no need. Through Profibus you can take all the inputs. Signal also you can take directly.
So you have the mapping for this one?
Yeah, we have the hex file. We'll give the hex file. Yeah, so here you give the milliampere.
Yes. We can measure the output.
Yeah,
Output is
50%
coming.
and analog output should come. Similarly, for you, 2 and 3 is not connected.
Not connected.
only
1 and 4.
1 and 4. Once you come out, the simulated value will be out,
Out. Yes.
and it will go to the actual. Similarly, you can test the relay also.
Release. DOs like
DO also.
DOs.
DO. Then you can select external solenoid valve. We are not connecting, so for this we need this two.
Okay.
Chopper motor IR source. You can see whether the chopper motor is on or not. You can switch it off, and you can check the chopper motor is off.
Yes, chopper motor.
Similarly,
On? Made in on?
it is off, right?
Off.
Now I will switch it on.
Okay, it's on. It gets on. Okay.
But this, normally we don't do this.
Okay.
Yes, if we put IR off condition means IR is off. Value will show error maybe.
Yeah, you
Not
will
measured.
get autocal drift
Autocal.
and
Okay.
lot of alarms are there. All the alarms are there in the manual. But what I am showing is your day-to-day routine, what you are doing. No?
Main things,
All the
basic things.
yeah. Now, so we have seen major parameters. Number 1, how to check the detector, how to check the O2 sensor, how to check the analog output,
Analog inputs,
ranges.
outputs, relays, etc.
Now the last is the calibration.
Calibration. Okay.
Just a second.